the idea is to look at why. Why do you need independence? Why do you need immutability? And then it will lead us to some conclusions, and we'll get to that. So that's pretty much done. I'm just going to do a bit of a publicity advertisement over there. It was the PowerShell Conference Europe not that long ago. Jeffrey was with us, and some other people I can see over there. That was a blast. If you have a chance next year, just come at the PowerShell Conference. WinOps, obviously, there's the meetups. And I write a few things about DevOps, not much yet, at devopscollective.org. And I recommend also looking at PowerShell.org. I come from an operations background. I started first line IT, like an IT pro, and then I went a bit in engineering before doing automation. And then now I'm doing some platform infrastructure as a service development or automation, as you want to call it. So that's me, pretty much, changing and then arriving more in the dev sides of things. So I've seen lots of nasty stuff, and sometimes I had to think, okay, I need to see what's wrong with the configuration management and what to do to make it a bit better, and how to convince people why this is the problem. And it's not only a problem with culture, or it's just the approach, which sometimes is a bit wrong. So first of all, I wanted to put the definitions up there. We already seen quite a bit with Michael Green, which explained that, and the other speakers this morning. Immutable, an object whose state cannot be modified after it is created. Simple enough. We'll see how that plays for IT pros. And then independence so can be applied multiple times without changing the result beyond the initial application. And we've seen, with Ed Wilson, we've seen an example of that in a script. And then not only you want idempotence, you also want convergence to a finite state. And this is what DSC does. It makes it so then you converge if you wrote the thing properly. So today we're going to try to have a quick look at configuration management approaches, how we do things, what did Michael try to convince us is the go-to way to do, and then what's the future. So we're going to go down the rabbit hole. We're going to see what people do and why they do it. So I like also, like Jeffrey said this morning, I like to know why people are doing things. And we're going to use the 5 whys, for instance, to understand a bit more what's going on with this. And try to have a paradigm shift and then a glimpse of the close future, and that gets back to Windows 2016, Nano server, and containers. But we're not going to go too deep, just the whys. So the approach is to look at bad the pets, the better the cattle. And I don't know if you're familiar with the chickens, but that's what we're trying to aim for. So this is an analogy that you'll see, hopefully is going to make sense. Before I start diving into the problem, I'd like to see a bit where you are in your configuration management journey, so I have a quick poll for you. I'd like to make the difference between web shop IT and more enterprise IT. So usually you have both in a company, but you work more on one side or another side. And web shop IT is where you directly try to, from your IT, your technology is used to drive directly customer values. You just try to sell something and to use something through your technology. And the other one is more to support the business functions that in turn is going to generate the values. So who works more for the enterprise IT? Yeah, and I guess everyone else is on the other side, web shop IT? Yeah, so that's not that many. Yeah, you do both. So usually you're more one or the other, but it's fair enough. Some people like Azure, if you look at Microsoft, Azure is directly selling things on the net, but at the same time they have all this, all the backend that needs to be supported, and then they support a lot of things. I think it's more than 100,000 employees, you said? At the company. So that means there's a lot of business functions to support, not only Azure. So that's an example. So for the enterprise IT, we would say that most of their tasks is automated, like building servers. Okay. And for the other group, how many of things more automated? Okay. But there's less web shop people around there, probably there with Richard down there to see what's the future for them, because they already have automated most of it. So I'd like to have a last poll is, what's the life expectancy of your servers? How long do you think your server, when you install them, how long do they last? Do you know if they have a finite state? So who thinks their server is going to last more than 2 years without being rebuilt? More than 2 years? So everyone else thinks it's less than 2 years, right? So more than 1 year. Okay, more than 6 months? Yeah. Okay. Who's under 6 months for a server? Wow. Better than expected, so that's good. All right, so we're going to see the pet. Do you know this guy? There, yeah? Do you know that character? So everyone knows? Yeah, well, if you know your servers the same way you know that character, it's probably because you have pets. So you've individually spent time to look at your server, to craft it. You know, it's uncrafted. You spend time for an individual server, and now you can see, oh, that's the name. Oh, this server has this, and that. That's your pet, probably, or someone you know's pet. Okay, and that usually doesn't sound really good in the IT mindset. So what's the mindset you have behind it? So you have a service, you're an IT team, and you try to provide a catalog of service. And you're told everything is mission critical. You just can't, nothing can go down, you know? You just can't take anything down. And if anything breaks, it's the end of the world, right? And this is the kind of discussion many IT teams have. It's like, yeah, you can't do anything. And downtime is not allowed. And if it's planned downtime, you really need to say, I really need to do some maintenance. And they say, yeah, sure. Come back in a weekend and do that during the weekend. We've seen that already. So why do we have that? Well, because downtime is painful and recovery is hard. Everyone agrees with that? When you have a proper downtime, yeah, it's hard. But we'll see a bit deeper why this happens. But what happens for the sysadmins, sysops? You build something once, and then you never touch it again. You know, it's like, oh, if it works, don't touch it. And then sometimes, even if that's the general theory, like, you've got a quick win, like, oh, I just want to do this. I just want to tweak that a bit. And that's never going to change anything. It's not going to break, right? So then you do a small win, and then you still touches it. And then management said, oh, you need to do that done by yesterday. So you cut corners. You say, well, if I've got to do that by yesterday, I need to, do whatever it takes. And that's risky. So in the end, because you don't have to, you cut corners, you don't update the doc, you don't trust the doc, don't use the doc at all. That's what Michael was saying this morning. And you say, ooh, what's going on with that box? Well, that's Bob's box, so it just asks Bob. Again, the example Jeffrey took this morning. And he's done black magic with it. I have no idea what's going on in there. He knows everything about it. And you ask Bob, if he's not on holiday, obviously. And Bob says, ooh, don't change anything. It's too risky. If you turn it off, it's never going to come back up. Everyone's seen that? Yeah, well, the discussion happens quite often. So I'd like to see a bit why we've got this. And then, yes, in the end, you have to do something on that machine, and you don't know, Bob's on holiday. You happen to try to do something, and this is what happens. This is what you get. And then someone's going and says, what have you done? I can look at that over and over again. And that happened to me, so that's why I had to say, why do we do this? So we're going to use the 5 whys to maybe go a bit deeper. So the idea is we've seen, because downtime is painful and recovery is hard. But why that? Why do we think that way? So my take is recovery takes a long time, so the business is impacted. Ops are busy firefighting all the time. And in the end, they say, well, that's the problem. But you need to go deeper and deeper. So what's going on? We thought we could control that change. We had a cab meeting, and then we say, yeah, that change is all right. But you didn't know every details of that change. So then something probably wasn't that all right. And we thought it had no impact, but actually it was more complex than whatever you raised during the cab meeting, because as Mike said this morning, we don't really care. We just argue about stuff, and we don't have proper data about it. So why do we have this? Because, maybe domino effect, the state of the machine was not as we expected. Thing was, hidden somewhere. Someone changed something, documented something else, and forgot one bit, which was actually very important, and, things go down. So maybe the person doing the changes did not know the exact configuration of your system. And this is where we're going to start to see, okay, so maybe there's a problem with, the configuration management. So the first type of problem is to recognize that it does exist. And it's not an HBO series that is actually Zig Ziglar saying that. So we're going to go down the rabbit hole, and we're going to see it as a problem. So it works really well, because what Michael said earlier today is exactly the same example I'm taking it in, and we didn't plan that. But you have a machine, a node, and you've got Mike, Scott, and Joe, engineers, that's going to make some changes to that node. Simple, right? So your machine goes from a state, a default state at the beginning, and Mike makes the first change. And you have a server which is in a different state. This is manual process. It goes in the box, RDP to the box, make a change, document the change, maybe, and then says, here we go, I'm done. Sometime later, Scott says, well, I got to change that state a bit. So I look at the documentation. Hopefully, Mike did everything and wrote everything properly. And I'm going to do just a little change as well, and forget to document it, maybe. And Joe, we know exactly what Joe is going to do. Just going to do something very simple. This machine doesn't have enough RAM. Let's add some RAM. What do you do when you added some RAM? You restart the machine. What could go wrong? So imagine what Joe did, or it's quite easy. We know exactly what he did. But what did Scott and Mike do? Maybe Scott didn't document. Maybe he was deleting system files or changing something that changed the system file. So then the machine doesn't work when you try to restart it. So you have a problem there. And then Joe can't know every step of the configuration. You see, your configuration is a transition between different states. So you've got the states you're looking at, and you've got transitions, which is the change you're doing. So my approach to that problem, I faced it a few times. My approach was, this is the problem we've got. It's like, it's like a mathematical problem. You've got different states, you've got transitions. Well, that sounds a bit like a graph. You have a transition between each, and then you have a state for it. So A, B, C, and D, these are states. And then A, B, C, C, D are transitions. When you install a package, you're not applying a state. You're making a transition. What happens after that, you resort to a state. And you need to remember those kind of things when it gets more complex. This is your default state, maybe the raw image. You install a package, you have another state, you configure the service you installed, you have another state, and so on and so on. Imagine that you have machines that evolve over 2 years. Sometimes it happens, even more than that. People are still running 2003 machines, probably they never rebuild it. And you don't know how many changes, how many transitions they had. And this is where it gets scary, because this is only 4 transitions. So for every transition, you want to be able to roll back. Something goes wrong, well, I want to roll back. Or sometimes you want to roll back, you want to replay it. This machine, the hardware is just going down. You want to replay. So you don't have a state, a definition of your state. You have only transitions that you know. The documentation, the runbook, usually you say, to get to D, you need to do A, B, B, C, C, D. And the problem is sometimes, well, you need to do that, you miss one step, is it still going to work if you apply the step after that one? And this is where idempotence starts to get in play. You want to apply this every time, and you should work it out. And then you need to have the rollback available. If something goes wrong, you need to be able to get back to the other one. And usually people say, yeah, I can install something, but then like the MSI doesn't uninstall properly and leaves like registry entries. And that can be a bit of a problem. So imagine your system, slightly more complex, and you have especially 2 end states that you care about, E and F. And over time, let's say E is one web server that you run, and F is another web server, web service. And you start from there, you want to be able to go there, and one day you say, well, I don't want this one anymore, I want that one. So you change. It looks complex, but you'll see why. This is what everyone is doing there without knowing it. You don't know all the transition you're doing, but you're still doing it. And someone says, you're a sysadmin, you should be able to get from any of these states to any other without creating a downtime. No one is saying it clearly, But when they say, well, do that change quickly, that means you're probably there, or you may be there, and you need to get to E. Have you ever tested that before? Or have you just tested from A to E? Or have you tested from here to here? So have you tested all your transitions between your state? And this is where it starts to get complicated to be able to say, well, I changed that, these people have changed that, we need to get into that state. So people, to avoid this kind of complexity, this is what we get to. We abstract the model. We say, instead of thinking of all the changes, we're going to say we have role E and we have a role F. And these are labels to say this is a state I want to be in, this is the other state I want to be in. And you abstract it completely, and then it gets to this. It's like, oh, that's easy. This is web server, this is file server. This is the way you do. You kind of abstract that, but sometimes this is in the documentation, or this is what you expect to be in the documentation. And then you need to redo that, and most of the time you need to do that manually. But that's much easier to relate to. So it's much easier to say, yeah, I want that one, or I want that one. And then everything that happens in between, you don't really care, do you? Well, if you're a sysadmin, you care, because this is your job, is to get from here or to get from here. And this is where it gets tricky, because this is the previous example were simple, where the machine has evolved for X amount of time. How many patches have you had? You know, one per month? Have you done that every month? Probably not. Why? Because it's really complex. So if we look at all this transition, just do the math, you know. We engineers, let's do the math. And this is the number of transitions you have when you think about your transition like this. So it's pretty linear. You say, okay, I support only the end states, and this is where I want to get to. In reality, when you do that, but because as a sysadmin, you need to understand every step, and then you need to be able to revert, this is where you get to. So this is what you're meant to support. Even if this is what I'd say your management or your management line says, okay, you need to be either F or E. And then if you change things, actually, this is where you get. If anything goes wrong, you need to be able to go back to any other state. That means you need to support every single transitions. And that means this is what you think you need to support. This is what you're supporting, all these transitions. And that gets pretty scary. So this is with another scale, just to see the more transitions you have, the bigger gap you have between what you believe you support, which is the end state of your machines, and what you actually support, which is every transition. So is there a way we can just support that? Do you have any clue? Well, this is where immutability comes in. There's a slide I want to skip, and that's not the one. Yeah, so when you've got these two states that you want to support, but you don't want to support all the rollbacks and everything, then immutability tells you that when you're there, you never change. If you, from A, you have a way to play to E, then you never change back to go somewhere else. If you want to go to F, you create F, you destroy E. Make sense? And this allows you to say, well, the only path to F is going from A to this. And this is you have real role, and you just apply something, and then when it's applied, it never changes. It's immutable, okay? And same for E. So you should try never to change that one. When F is done, it never moves, it never changes. If you want something changed, well, you create a new one, and as Mike said, you just change the load balancer to do the other one. That's a very simple example. And that's usually why it works very well for web servers, because they're kind of stateless, or it's easier for them to do that. So how do you do that with your SQL server or your Exchange server? Well, this is one of the problems. And I have a bit of time, so I'm gonna go on that one. So this is a common scenario when you try to do you try to simplify your architecture or to get faster to an end state. And you have this one when you say, well, clearly, I always need to get there, and then from here I go either there or there. And that is usually your template, your golden image, these kind of things. Very interesting concept, fair enough. I've seen places where they go there, they ditch everything before it, and then from there they just change it change it, change it, change it, and then they need to go to either one. If they need to change the OS, they will need to redo that manually, completely. And that's a bad case. When you have a golden image, it's not golden. It's a transitional state. You're going from a state, from a raw image probably, to an end state. This is just a way, it's a checkpoint, so then you get to another one faster. It's never something immutable over there, it just changes. So you need to make sure all your changes are recorded. And again, if your changes are text file, to some extent, and you version them in Git, then you can, if something changes before, you can rebuild it to there, and then rebuild to the quicker and much more manageable way. So, the cattle. So that's the next step. You get there. So how do you identify those, one from the other? Well, you can see they've got little tags, and that's all you should care about the server. So a cattle is a server where you don't really care about the server itself. What you change is the mold. You have a mold, and then everything in there, whatever is deployed is just from that mold. So you know exactly what it's going to look like in production. And that shouldn't change. You just manage that mold. So the mindset is slightly different. And this is what the IT mindset should look like. And that's what DevOps is trying to push people to do to some extent. You want to have a catalog of service. You want to have a high mean time between failure, and especially a fast recovery time, the MTTR, mean time to recovery. You want to have a very low MTTR. Something goes wrong, you can find out because you have everything sourced in source control, and you can roll back quickly, and it's fine, you can work it out. It will die anywhere at some point, so you have to aim for those. Assume it's going to break, and when you know it's going to break, just focus on these two. Quick recovery, you can't really avoid failure. So then you need to have a minimum unexpected downtime, and you especially want the downtime not to be because a configuration change that someone did manually, no one knew about it, and they went directly on production, let's open RDP, and then let's change things, and then it breaks, or sometimes it breaks later. That's even harder to troubleshoot, Someone restarts it, and then boom, or someone changed the service, boom. And then you say, well, what happened? Well, you don't know. Like if the service was running and you changed some of the files you were using, maybe they were cached into memory, and then boom. So the downtime of the server should not be the downtime of the service. This is what you should aim for. And there's different, so you have designs to do that, high availability, clusters, and this kind of things. But it also depends of how you manage your configuration. If you don't care if you have the mold, something goes down, and before it affects your service, you just spin up a new one. And you know it's going to be the same, and you have tested that it's going to work the same way. So this is what you should do as a sysadmin. You should look at, I call it policy-driven infrastructure. Actually, it's Don Jones that started with a very good article about if infrastructure as code was not the right thing to do. And he's trying to emphasize that what's important is not the code, it's the policy. Having a policy that defines your end state is really important, and that policy being able to, being understandable by a computer as well as a human makes a huge difference. And then you can leverage that as in your Git repository, your change control from Git, for instance. So that, I think, is a very interesting thing. You should look at the policy, not changes. You have a policy, and you make it so. Again, Jean-Luc Picard. And versioning traces changes to policy. You don't have to have a big change control, like if you want to make a change, these are the forms you need to fill. You need to send them. No, everything's in change control. Everyone use Git? Everyone use Git? Pretty much everyone. Everyone should. I think everyone should. Or Git or SVN, sorry, source control, yeah, everyone? Source control. I say Git, but I know some people around there use SVN for other reasons. But yeah. There you are. Been there. Change your company or change your company, right? I used to work with them. Sorry, I couldn't help. But they're making much progress. So what I failed to do, actually, they're working on it, and they're making it progressing. So I say, well, I did something wrong. Probably the communication wasn't wrong. That's why I'm working on those kind of things now, being better at it. So you need to test thoroughly and all its dependents. So if you change something, imagine a tree. When you make a change somewhere in the tree, you need to test everything dependent on that tree. That means your test should trigger the other test or everything you depend on it. Everything before doesn't matter as much, but maybe if you have integration with a complex system, and you will have, then you should do all these tests again. And if you start by thinking, okay, my infrastructure needs to be tested, then your mindset when you're building it, say, well, how do I test that? And then you change your mindset, which is a bit what TDD does. It's not because you need to write the test first, then you will have the test, so then you can just run it. It's just to be able to write the test first, then your mindset needs to shift as well, to be able to say, how do I test what I want to do? Well, I need to know what I want to do. Anyway, TDD is another story, but even for infrastructure, I really recommend having a look at that. And does it have the expected value? This is, I refer to lean. So again, what Michael Green, the reading list from Steve Morosky, I really recommend it because this is also my reading list. So here you go. And does it work without causing an outage? When you deliver something in production, a server, that gets back to the operation validation. You need to make sure that does it do what I expect to do in its context? And this is the operation validation. And how do you keep it consistent over time? Well, if you allow people, you have these things working, and then you have DSC running, and then you still let people with admin access everywhere being able to RDP to your machine and change something, you're going to have drift, obviously. Someone will change something that's going to break. If you have DSC configured properly, it's what Ed Wilson said this morning, like, install the GUI, and that removes the GUI, and then you want to install the GUI again. So that's what can happen. And yes, this is just a release pipeline model. And actually, I took most of those from the document Michael Green said. So have a look at that. It's 56 pages, but it's quite easy to read. So don't worry too much about it. And the screenshots, easy. So why does this work? You know what you're expecting, the policy. You know what has changed, by whom, and why. This is what you've got in the versioning. And you know they works because you tested them. And you know they delivered because of the operation validation and the avoiding configuration drift, which is something you can implement and should implement as well. I'm sorry. So this is what Michael said, so I'm not going to repeat it. If something goes wrong, well, you just write the test and it's never going to happen again. Something else will break, but not that one. The chickens. What are chickens? Have you ever heard of this analogy? So you know, people know pets, yes, cattle, and then chickens. Who has heard of chickens? Yeah, probably you watch Jeffrey's talk. So you can see that's very different from the cattle. So cattle only a few big things, like if one cattle sometimes is not feeling really well, then it's probably cheaper to just fix it than to buy a new one. The analogy for chickens is a bit horrible because if one kitchen is sick, then you get rid of it. So poor chicken, but for server is a good thing. It's something which is harder to get to, but it's a good thing. So then instead of spending time trying to fix it, the unit, you fix the mold, and then, well, this is not of any use anymore. You just bin it away. You get a new one. Quicker, easier, cheaper. They're much smaller, so they have a small footprint per unit. And they're cheaper to replace than fix or change. And you don't really know the difference between those. You're just like, oh, this is, I don't know, white goose, no, that white chicken, and then you don't really know which one it is, blacktail, whatever. You just know this is these kind of things, and you don't know the details of each of those. You don't even have numbers. Would you count them? I wouldn't. So why aiming for immutability? And this is where we have trouble at the moment, because you don't want to install SharePoint every day, do you? Or at all, but that's another problem. So a big footprint, like let's say you have a Windows email, which is 100 gigabyte. Well, if you got to spin one up in the cloud every few hours, I do that every day, I can tell you, this is a pain. But it takes really time to generate and distribute. Let's say you have different data centers or different places you want to run that. You change your image, even your golden image, you patched it, you need to distribute it. Well, you can come back tomorrow at best, and then you need to carry around. So you have dependencies, and you have servers that are not only SharePoint, but I don't know, If you're crazy, you can try to put, I don't know, something else on the server, Exchange, or that's a very bad example, but who knows. So you try to collocate because you want to save money. You know, you have one big server, you pay the license, and that's very true for small companies, and they want to add more stuff to it, and that does a bunch of things. And then you can't really take one down because that service needs to be changed because you rely on the other one to be still up, and that's another problem. So and sometimes you want the transitions you support are just cheaper. So if you just want to add some RAM, do you think you're going to rebuild your server, your SharePoint server, to add 4 gig of RAM? Maybe you should. Probably you wouldn't care enough, because you know if you add more cores or more RAM, it's still going to work the same way. It's going to be more performant, it's going to be better. And you can offline patching an image as well. So there's ways where it's cheaper for you to go that way, and it makes sense to you, because otherwise the overhead is just not worth it. So whenever you support one transitions, which is the change I was mentioning, make sure they're explicit. If you say, this is the only, you have state E and F, from A we support from one to the other, make sure that if you support anything else, like adding RAM, it's an explicit transition you support. Don't say, yeah, we support any changes to that from that state. No, make sure that the only thing you can add is adding core, adding RAM, or whatever you think will never change the actual functioning of your machines. Because if you start doing other things, they will expect you to just change what is running, which is not really helpful for you. So the chickens. Well, containers and Nano server are the chickens. We've seen with Jeffrey's talk this morning, they have a very small footprint. And, yeah, sorry, it just turned off. Sorry. So they have a very small footprint. They can change, and you can change them, test them, and distribute them much faster. So your release cycle, your build cycle is much quicker. So then it's easier to make a change to the base image. It's like, you know, Docker containers. You can change that very quickly. So you shorten the iteration in the feedback loop. You start something, you run into your machine, you test it, and then for you, developing is much quicker. And I'm going to show you that in the demo very shortly. It's much quicker when you have a small footprint. I have a big footprint there with a full-fledged Win 2012 R2 server, and that takes some time. So if you can make it faster with a smaller footprint, less surface of attack, much better. The other thing to look at is decoupling the tasks. So microservices architecture is not just a nice word for developers. It's something that as operational people, you should say, well, encourage that. So if you have the infrastructure that enable people to have tiny things doing very small units, and you have just to manage that, you can try in development, push it to prod if you want to, very easily and very quickly, then they will have a feedback loop much smaller. And that allows you the immutability. So I see immutable, the containers as two ways. So container is a transparent sealed box for dedicated service. What I mean by that is you can't change it when it's done. So you're given by your developer, for instance, a sealed box, and then you can't poke inside, but you can see what's in there. So you can see what you need. And usually you don't really care. You just send it, and then it's deployed. When they tell you, well, we don't want that one, we want the new one, you just replace it. You don't change it. You don't patch your container. I hope that was clear. You don't patch your container. When it's there, it's there. If you want to change it, you just deploy it again. And Nano is more like a headless server, and it's cheaper to replace than fix. So if you can deploy a new one, 400 megabytes, how long does it take to download it over the internet at the moment? Nothing. So you may want, it's probably, you can aim for immutability with Nano server, and you should. There's always, in the workflow, when you start trying to go for immutability, you will need to start prototype it, and that's going to take manual work. You're going to say, what if I do this? What if I do that? But you should not do that in production. And then say, yeah, but spinning up a test environment is expensive, it's time-consuming. No, because you should have the test already. This is where you start by testing your infrastructure. My infrastructure needs Active Directory, X amount of servers, so I have Active Directory template, as in policies, and just spin how many I want. And then I need also SQL Server, I spin up how many I want. It doesn't really matter. And then you can test them working together. So, quick summary, use the release pipeline model. I'm not going to say it enough, but just use it. This is something that sounds new, especially to Windows type of admins. But it's been there for quite a while, especially for developers. I've used it for a very long time compared to Windows Ops people. Many things they're doing help you out. If you think you don't have time and you have too much overtime or working on weekends, that's probably you should use that more. If it's painful, do it more often. When you do it more often, you're going to have to go, to polish the edges, and that's going to make your pipeline more streamlined, and it's going to be easier for you, and change is going to be easier for you as well. So don't migrate, reverse engineer your servers from what the state they have at the moment, and then you need to find out what's the configuration, what the policy you can extract from them. Don't try to use tools to do it. You need to reverse engineer what you already have. That means document what you don't have documented. If you have a proper documentation, then that's going to be much easier to do. And test your convergence and validate the delivery. I'm going to show that in a minute, what I mean. Manage your server like cattle. You define the roles you need, the configuration management, make it so. You should not go and change your servers. Please don't do it. This is the source of your pain. So it's hard to get there, so the transition is really slow because you need to go for every server, make categories, and find every policies you have for those, but don't do it manually. And their name should not matter. You'll find this is something which is really hard to apply because you want to have a reference to say, okay, this is this role, but then the role matters, not the name of the machine itself. And aim for chicken. Try to think immutability. So if I tell you, you have this server, how long would it take for you to rebuild it? I should say, like this, I press a button, and then I don't think about it anymore. That means you need to have your pipeline, building your machine from the ground directly up with just the press of a button. If you've done that in your development cycle, that means you say, well, I need a new file server. How do I go about configuring it? This is where you define your policy, and you make sure that DSC, for instance, does the job for you, and you validate that job is doing what you expect. Then the next time you have to run it, you just run that configuration you had, and it just does it. So think immutability, microservices in the design. Nano server, obviously look at it, because as Microsoft migrates roles to Nano server, then it would be much easier for you to manage those roles. So I'm waiting for more things on Nano. Containers as well. If you have developers especially, just push them to use containers. You have to understand how to support them to do it, or you can automate the deployment, and you'll see it's not that complex, and there's lots of information about it because Docker has been there for a while, and you can use Docker on Windows, so that's an example. And event sourcing, I'm just going to put it there. I strongly recommend you to have a look at that. It's kind of a developer thing, but I truly believe that for ops people, you need to have a look at that and think about this in the future. Very quick summary for event sourcing is like everything is a succession of events, and what you need to record is those events, so then you can replay it completely. I think that's really important because you don't really care that much about the state of what is it now. You want to say what events did it go through. So have a look at that, and that's quite important for operations. So that was me. I have a demo, because I have a bit of time. And I'm going to show you. So my approach for the demo is like, how can I demonstrate immutability? No, I think you don't really care about that. What's important is how to get there. And you've heard today about DSC. You've heard today about all these tools. So how can you try to do something? And I'm not a test kitchen expert. I used to do that without test kitchen. I started that last Friday, and I just did a very quick demo. So what does it do? You say, this is my definition. You run kitchen test. And it creates the new VM for you. It connects to the VM. It configures the VM based on your configuration. It makes sure that the operation, it validates the operation. And then if it passes, then tears down the VM and you're done. Easy, right? So it does most of this for you. And I use Hyper-V on this one, but you can use drivers. If you're familiar with Packer, it's similar to Packer. And you don't need to know Chef or use Chef or Ruby. Like I do everything in PowerShell, and I honestly, the only thing you need to know is how to edit a text file. It's a YAML file. And this is a link to getting started. And this is the workflow I'm going to show you. So the slides and what I'm going to use there is on my GitHub repo. So have a look. It's WinOps Conf, and it's going to be there. So let me just switch around and duplicate. And I don't think it's going to work right now, but I don't know why. I'm going to show you. Oh, no, actually it did. And I want to show you that. Maybe. That's funny. I don't even know how to. Okay. All right. So this is the kind of configuration you have to do. I'm going to run quickly through this. Actually, I need to run the other thing here. Yep. So as this is going through, it's going to take some time because the first thing it does is clean up any older VM that I had, which I just ran to make sure the test was working. And it will. Can you see? Everyone can see it? Yeah? No? Yeah, I'm sorry for that. Better? So it just goes through, cleans the VM, checking the files, and I'm going to show you the files. What it's going to do is going to spin up the VM, make sure what I've configured to test the DSC resource I've got is going to run properly, and validate that with a pester test. And when this is done, it is going to remove the VM. So the configuration file is quite simple. You define the driver, you define the transport, which is WinRM for Windows, and you define the provisioner, which is say, okay, use DSC to configure it, because you can use Chef as well. This is a Chef tool, Chef.dk development kit, but I use it only for DSC for this example. And this is the way, if you go home today and you have Hyper-V on your laptop, this is a Surface, so I use that on my laptop right now. The only thing you need to do is install Chef.dk. I've put the link for Steve Mirowski's quick install. So you install Chef.dk, then you have a few packages to download using some commands you put it. It's very easy, like this 3 packages or 4 packages to run. And then you have to create a YAML file like this. You can take this one from my Git repo. And then you say, I want to use Hyper-V. This is where my VHD is. This is the name of the VHD. This is something I use just for unattended XML. I want to make it clear. You don't need that if you have an image. What I did, the only thing I did is I took an image from Microsoft Download, like the evaluation 2012 R2. I installed WMF5 because it's easier. I run the updates, and I sysprepped, and I use that there like this. This is the only thing I do. So. And then for that one, there's a README file, which I'm going to put the details in. This is a pull request I've done just to allow to have this an ISO as a DVD-ROM when you start the machine, so then you don't have to do the configuration manually, like setting up the passwords or selecting the time zones and stuff. Details, this is network, because there's no network here. WinRM, this is my username and password for that VM, which is configured in that XML file. I say DSC, use WMF5 to configure it, because the LCM kind of changed. And then reboot if needed. This is where my configuration examples are. This is the name of my configuration, which I'm going to show you in a minute. And the verifier is just running. This is the equivalent. So when you run that and you build your definition of your server, in the end, where is it? Yeah, in there. This is going to be your operation validation. That means is the machine configured the way I want it to be? And this is the platform you're using, the name of your VM, parent VHD. It just creates a diff of the VHD, so it doesn't change your actual VHD. So then you can just reuse that over and over again. And this is just the name of the ship. A quick look at what it does. So has anyone looked at DSC before? A few, yeah, a few. Yeah. It's quite simple. And I thought the easiest way to show the principle, sorry, that's the test, is this. It's a simple configuration which is using a script resource, and this is the way the format it does every time. So even if you use this is not declarative, this is imperative, so you should not use that, but that gives you the context. And that's what Ed was saying this morning. You have a get, you have a test, and you have a set. You set only if the test returns false, right? So I really created that for something very simple and quick to run, so then you can experiment with that. But as soon as you've run that once and you understand what it does, go and look at GitHub of the many examples you have, and then you will have proper declarative syntax. Say, I want this package to be installed. I want to install, I don't know, RabbitMQ. Just install the package. That's it. So this is what's running. You're just creating a simple text file, ensure it's there, and then return. And if it's not there, it's going to do it. Otherwise, it's going to return, yes, it's there. And the test I'm doing, this is a pester test. If you don't know pester, well, you can see that it's not that difficult. Anyone can read that and probably understand what it does. So I went for something very, very simple. And hopefully, yeah, I had issues this morning. Oh, no, it's there, actually. You see the WinRM transport. No, you don't see. There you see. The WinRM transport has been established. It goes to the Hyper-V. It connects to it, and then it's going to send the files over the WinRM. And that means you don't have to transfer the files automatically. Everything happens. So I'm probably going to stop there so that Pete can come around.